Good morning. Well, I have most of that in there. So this is what's happening this week. Wait another minute. Right now we don't have anyone. But I'll start in, it's 11:31. So we have one person. So I'll go ahead and start. So this is what's happening this week. This is May 11th to the 15th. So the electromagnetism CER is due today. That was posted last week, so you already have that one. You get to choose. So I believe there are 3 different ones, and you get to select the one that you want to do. There's an electric bell, there's a speaker. I don't remember the third one. Third one might be the nail wrapped around the wire, like the lab that you did last week. Suggested is a study guide that should have posted this morning. The quiz, there's a quiz on electric circuits Wednesday. So that will be posted Wednesday morning, and you'll have until midnight to do that. If you don't get it done during that time, then I'll have to post a makeup quiz for you. Then we have another lab that's coming up. And again, that has not posted yet. The 3 of us were each, why so much? I don't know what's so much. You were given this one last week. The quiz is due Wednesday, and then the lab is due on Friday. It's 3 assignments. Should take you maybe an hour and a half to do all 3. Suggested, that means it's not required, so you don't have to do this one. But the lab is a lab, so that counts heavier than the assignments. So after you've done the quiz, we have the inquiry stations. And like I said, the 3 of us physics teachers are coming up with the different videos that you need. So it's like the 9 inquiry stations that you did for statics. We're trying to come up with those videos. I've done mine. We have 5 videos altogether between the 3 of us, and I'm waiting on 2 more from another teacher, and then I'll get this posted. All right, I'll post it with just the 5. And again, it's your choice. I want you to watch all 5. But it's your choice which one you want to do a video about. You can do that with another 1 or 2 other people if you would like. But it needs to be very clear who this video is representing, okay? And then there's an extra credit assignment that's due on Friday. But again, for extra credit, you have to done all of the week's work in order to be eligible for the extra credit. I've had a few people turning in things, and that's the only assignment they turned in for the week, so they don't get the extra credit for doing it. So try to stick to the CER. And again, if you have to manage your time, the CER is less significant in your grade than the lab. That this is not posted yet. It will be posted as soon as I get the other 2 videos that I'm waiting on. And then, of course, the quiz is important. If you're missing one of the quizzes, you need to get to that as soon as possible. We only have a few more weeks left to get things wrapped up, okay? So that's what's happening this week. I'm going to go over the study guide today. So if you want to pull that up now and work on it, go ahead and do that. And I have the questions here. This is about circuits. So what are the rules for calculating resistance, current, and voltage in series? Whoopsie. I could have swore I had them here. Here they are. So these are our rules. There's one thing that I do want to add on the bottom there. So series, it's a one-way path. So after leaving the voltage source, you have to follow the wire. You get to this point, you only have one choice of direction. You have to go through this bulb or this resistor to continue the circuit, and then you have to go through this bulb to continue the circuit. Only one-way path. Parallel, you have multiple choices for your path. So starting at your voltage source, you go through the wire to this point, and there's a choice. You can either go through this bulb or you can continue on the path. So current is the same everywhere in series. Here in parallel, voltage is the same everywhere. So you see there are differences between series and parallel. Resistance adds up in series. So in series, we'll get into this in a little bit, but we add the resistance of this one to get our total resistance. But in parallel, as we add more resistors, the resistance drops. Resistors are added. Oh, yes. Resistance drops as resistors are added. So that means, like being in line waiting to pay your toll, if there's only one toll booth open, it's a long, slow wait because there's a lot of resistance to get on your way. But if another toll booth opens and another one, if you have 3 toll booths instead of 1, you're going to get through that toll gate much quicker with a lot less resistance. So the more of these resistors that are added, the more the resistance goes down. Okay, that's in parallel. That's not the case in series. When you add resistors, they add up. So you increase your resistance when you add resistors in series. Voltage for series circuits, voltage is split among the resistors. So if we start out with 10 volts and both these bulbs are the same, 5 volts will be used for this one, and 5 volts will be used on this one. But here in parallel, voltage is the same everywhere. So that's a pressure that's pushing the current along is the same everywhere. But the current is split up among the resistors. So if all of these resistors are the same, they each have 1/3 of the current. All right. Let me add one more thing on here. So what happens if we take one bulb out of this circuit? What happens to the rest of the circuit? Oh my hands aren't working. There we go. So if we take one bulb out of this circuit, both bulbs go out because we do not have a complete path. But here in parallel, if we remove one of these bulbs, we can still have a complete path through this one or the third one. So if we take out one bulb, we still have 2 complete circuits there. So the other bulbs will light. All right. So that answers question 1 on the study guide. Number 2, if voltage is increased in series, what happens to the current? So we'll take a look at Ohm's law. Let's see if I have Ohm's law on one of these. No, I don't, so I'll have to erase this one. So if you remember, Ohm's law is V equals IR. If you want to use the pyramid, voltage is increased in a series circuit. What happens to the current? So voltage is proportional to the current. So in series, if the voltage goes up, the current goes up. And that's true in parallel also, but if resistance is increased in series, what happens to the current? So these are both on the same side of the equation. So let's go ahead and put the resistance on one side. So using Ohm's law, if we want to know resistance, we have voltage divided by current. Oops. So can you see that resistance and current are inversely proportional? So as resistance goes up, the current drops. Okay, so as resistance goes up, the current drops because they're inversely proportional. 5, what are the rules for calculating resistance, current, and voltage in parallel? We already did that. So if resistors are added in parallel, so this is series, this is parallel, so are we on 5? No, we're on 6. We said that the equivalent resistance drops. And again, that's because of the toll gate story, or the same thing if we're trying to get out of the classroom. There's one door. If everybody's trying to get out of that one door in an emergency, it's going to be slow going. But if I open up the other door, it's going to be a lot quicker, a lot less resistance. So if resistors are added in parallel, resistance drops. All right, number 7. What happens to the current if resistors are added in parallel? Well, the same thing over here. If the resistance drops, what happens to the current? These are inversely proportional. So as resistance drops, the current increases. And last question is, if voltage is increased, what happens to the current? We see that voltage and current are directly proportional. So if you increase the voltage, the current also increases. All right, so that's the study guide. Let me see if there are any other questions. Okay, so Jamar, why don't I go ahead and take a look at what you're missing and we'll pick out the important things, okay? I'll send you an email. What email do you want me to use? The one in Google Classroom or the one in Remind? Jamar? All right, are there any other questions? Darren, do you understand what lab it hasn't posted yet? Okay. So I'm not getting responses. You'll have to send me an email if you still have questions then, okay? All right, well, you take care. Have a good week, and I'll see you again on Wednesday.